Alright, so as you can see by the title, in this video we're going to talk about the nuances of plant networks. And this is very important to understand if you work on the OT side, if you work on the IT side, or if you work in any manufacturing environment whatsoever. Because today we're going to discuss and lay the foundation as to why this is important and why it is different from the home networks that we're used to seeing, why it is different from the office networks that we're used to seeing. And so if we take a step back in history, right, so we all understand that nowadays it is common to see Ethernet-based networks on the plant floor, but it wasn't always the case. So back 30 years or so, if you look at an electrical panel, you would have probably found one of two things. So there were already a lot of different PLCs, so we're going to just draw a rack of a PLC. So this is a PLC with different I/O cards controlling different machines, right? So for example, here we have some kind of a tank system, and we have a connection from this I/O to these VATs that are going to measure, for example, level. They're going to actuate perhaps certain pumps. And again, I'm not expecting you to understand the ins and outs of control systems. All I'm trying to say is that there was a lot of I/O controlling different devices and machines on the plant floor. As these control systems evolved from PLCs and I would say like relay-based systems, and I'm going to obviously not draw this to scale, but imagine just a bunch of relays on 110 volts AC controlling some of these devices, right? And you had different communications. You could, for example, turn on maybe a mixer motor that's going to actuate the mixer within the tank. There's going to be a temperature sensor that's going to measure the temperature. And so a lot of different field I/O started to evolve as well and be a lot more configurable. And that basically meant that we needed to pass information from the PLC to the device and from the device to the PLC. And that is how some of the earlier protocols were born, and you can still purchase devices that utilize some of those protocols. And one of the most common ones, I would argue, would be Modbus. So Modbus is going to basically pass registers from the PLC to the device and from the device back to the PLC, and it allows you to have more granular control than you would via a digital type of a device. So in this case, if I have a relay that's going to just close the signal to the motor, all I can do is turn on, turn off. If I have Modbus to that specific motor, and let's imagine that now we've added some kind of a drive, right? So this drive is going to be obviously connected via 3 phases to that motor, but now I have Modbus, a connection to that specific drive. I can set the speed, I can perhaps vary the torque, I can maybe change the frequency, which is going to vary the speed. I can set other parameters, I can set maybe voltage, right? So you have 3 phases coming into this VFD, and that is obviously going to be set by the transformer or the upstream system. But in this case, maybe I want to change the motor type. Maybe I want to run at 230, maybe I want to run it at 480, right? So there's going to be different options that you can set via this drive by using the Modbus registers. And so Modbus, I would argue, was one of the fundamental protocols at the plant level that began to start this networking requirement, right? And so as you get into more and more complex networks, Modbus becomes a difficult protocol to manage, right? Because it simply does not necessarily scale as much as Ethernet IP does. But before we get into Ethernet IP and Profibus and Profinet, I wanted to discuss some of the other protocols that started evolving as a result of needing plant floor networks. And so if you're in the world of Allen Bradley or Rockwell Automation, you will have likely heard of DeviceNet and ControlNet, right? And so why were those protocols important? Well, there's going to be different protocols on the plant floor depending on the needs. And so once again, it's important to take a step back, maybe 1 decade or a couple of decades before Ethernet became so popular, and understand why those protocols were necessary. Well, having worked a lot with DeviceNet and ControlNet, I can tell you a couple of different things. So number one, DeviceNet allows you to daisy chain devices, right? And what does that actually mean in practice for the plant network? Well, imagine that for a second, you have a lot of different devices on this specific VAT. So what you want to do is reduce the time it needs to wire, but also you're going to basically put a block here that allows for different connections, right? So here I'm going to have some kind of a point IO module, and on this one I'm going to just copy paste the same, and this is going to connect to different sensors, mixers, valves, open and closes, whatever. DeviceNet, so instead of having that in the same panel, what DeviceNet is going to allow you is to run one single cable and connect to this module. And then daisy chain, so run from this module to the other module, and then run from this module to something completely different. And by having different addresses, again, this is not IP addresses like we've discussed on the home network, this is going to be DeviceNet addresses, you're going to be able to daisy chain different things. So this is not only applicable to your device blocks, it can also be other motors. So for example, here you could run a motor or a VFD on this specific DeviceNet loop, and so this became incredibly useful in saving a lot of wiring time, but ultimately it placed a load on the programmers to know the network, how to configure the different registers, and it is not trivial, right? The next item that I do want to discuss is ControlNet. So ControlNet was a very interesting protocol, and if you haven't worked with it, I would recommend that you at least read some of the documentations and perhaps watch some of the videos. We're not going to go into a lot of detail, but what ControlNet did is it made networks deterministic. And that is a very important nuance that you want on the plant floor that you don't necessarily care about as much on the office or home network. So what is deterministic, right? It is basically just a term that doesn't mean a whole lot unless you've experienced and lived through this problem. Well, imagine that you have a high-speed line, right? So you're going to have some kind of a conveyor that's going to have different indices of product, right? So here you're going to have a widget, here you're going to have a widget, here you're going to have a widget, and that's going to connect to some kind of other conveyor which is going to pick up those parts in a different segment. And then there's going to be some kind of a maybe stamping process happening, and here there's a labeling application with a vision system, right? So this is going to be an inspection station. So, well, why is this complicated? Well, because it needs to be highly reliable. And so deterministic means that the network is going to send signals at a very specific rate. So I've worked on very high speed applications and very fast lines where this was critical, right? So again, so imagine you have a ControlNet card that's going to connect to this motor, and again, I'm illustrating this by drawing lines, but basically this is going to be your servo drive, for example, in this instance. And so the PLC, every 5 milliseconds, so 5 ms, this drive is expected to have an updated reference for where it needs to go. The same happens with this one. Every 5 milliseconds, that network is sending out the position for the drive, and so it is very repeatable. Now, if we look at something on a home network, so if I'm going to pull up my phone and watch a video, for example, one day it might load a little bit faster, one day it might take a little bit more time. It is not deterministic. It's going to jump through a lot of different switches and routers on the ISP side. I will eventually get to watch the video, but the user is okay to experience a little bit of quote-unquote lag as a result of using that system. In this case, that wouldn't be possible because a shift or a miss of signals is basically going to cause a big crash between my conveyors that expect to be updated simultaneously and move in sequential motion. So ControlNet was a revolutionary network for the plant floor for that specific reason. Now, as we continue our conversation about the nuances of plant networks, understand that the requirements of the plant are going to be different than, once again, watching a video or loading a website. So this is a very key takeaway that I want you to take from this lecture, that in the early stages, as these protocols began to evolve, we had different requirements of the plant in mind. Now, with the entry of Ethernet IP or Profinet or Profibus, those protocols were so fast that we were able to get down to this resolution without it being deterministic, right? And so there's going to be ways to make the signals basically fast enough and double check the packets that are coming in, but those protocols are not inherently deterministic. It is only a byproduct of the speed that we're going to again discuss in a different lecture, that we were able to make this happen on Ethernet IP. What is the challenge with this, right? Well, in the past, if you had a PLC rack that's going to communicate over one of those proprietary networks, that wasn't necessarily a problem. These devices were not communicating. So for example, if you wanted to put the PLC on some kind of a remote connection and you wanted to give an engineer access, right? So I'm going to draw this as an engineering workstation, but again, this could be a server, this could be some kind of a desktop on the plant network. But if you wanted to give it access, the engineer was able to get to the PLC and through the backplane was able to see the configuration of some of those devices. The challenge as we migrate towards Ethernet IP and Profinet based networks is that they're going to have to place and assign IP addresses to the devices that previously did not have any. So basically what I'm trying to say is that we need to understand the nuances of the plant networks as we slowly transition towards the newer ways of doing things. Therefore, we need to understand the architectures and how that's going to drive the change as well as the deployment of some greenfield applications. If you have any questions on the side, if anything was unclear, if I forgot to mention anything on the plant side, there's going to be a lot of different variations, of course, if you're going to work in oil and gas versus food and bev and CPG, the differences and the nuances are going to be different. And when I say, by the way, when I say plant can represent many things for different manufacturers. It could be a coal mine, it could be an oil and gas rig. So don't take some of the words literally, try to understand how the architecture overall is going to fit your specific scenario.